So you can actually write your matrix to disk just by attaching the write message and clicking it, and it'll call up a save dialog, and you can call it planet colors. If you save it as planet colors, then you can read it back with the read message, planet colors. Now when you write, it wants to call it matrix.jfx. Just delete that whole thing and call it what you want to, because when it saves it, it's going to stick .jit at the end. When you read back your colors, you can read planet_colors, and it will read those colors back in. Then we actually are going to need a button in addition, because we won't see the changes. It'll read the colors in, but they won't actually be sent out of the matrix. So we'll generate some different arrangement here, and then get back to the arrangement we like. Having to hit this button is an unfortunate extra step. You can actually use the right outlet of jit.matrix to hit that button for you. So when you hit read, it will automatically output the new colors. So get some other colors going in there, and then get back the colors we like. The final thing I want to note about this is that you can, of course, have these colors load automatically when you turn on your patch just by connecting this main toggle through a button is the best way to do it. Toggle to a button to the read planet colors. So let's just save it and close it and see that work. So I'll open up the patch, and I get my city, and I already have my colors loaded, and I can jump to any one of my saved positions here. And I don't even need this jit.noise and jit.gen anymore. I could actually remove those because my colors are saved. But I'll leave it there just in case I want it as notes or want to study it again. So that actually is a good moment to bring up send and receive, because as you can see, Max becomes a mess of patch cables. There are multiple ways to send wireless connections, and the simplest one is the send object and the receive object. So if I say send start, anything I send into the send start object, like for instance the toggle, will come out of the receive start object. So now these two toggles are synchronized, send and receive. That enables me to have things happen by remote control. So when I turn on the patch, this toggle, the one of this toggle turning on, will be sent to the named address start. And over here, it'll be received at the name address start and read in my planet colors. What you really want to do is use color here. You want your send and receive objects to have the same color in the bar so that you can easily find send and receive pairs on the screen. So here we have 4 things going into this inlet. This is a perfect, we have 5 things actually going into this inlet. This is a perfect place to do a receive poly fizz. Hook it into that inlet, and then send polyfizz. We'll just take everything that's going to polyfizz and connect it to a send polyfizz object. So these patch cords that are stretching all across the screen now are replaced by send and receive pairs, and things are much cleaner. And you can go through your whole patch and use sends and receives so that you have less patch cord clutter. You can also put sends inside of encapsulations. So for instance, I can I can de-encapsulate building position here and re-encapsulate it with polyfizz in my encapsulation. And now when I open up building pos, my send is inside there, so I no longer need any patch cord coming out of here. This send is a wireless connection to this receive. And as I've said, color coding is very important, so I'm going to go through and color code all the send and receive polyfizz objects. And I should also color code the one that's inside here. And you may want to remove other color coding so that it doesn't get confusing. The next step is going to be to work on a little bit of lighting. Let's make a jit.gl.light type spot position. We'll put it off to the side and above. We'll put it like 10 meters to the right, 10 meters above, and maybe 5 meters towards the camera, looking at the center. It's got a very hard edge spot. That's cool and that's dramatic. We can give it a little bit of spot fall off. There, that's a nice softer edged spotlight. So now our city has a much more dramatic illumination. The problem is our planet doesn't have any illumination. So let's make another spotlight, and we can put it in the same location, but this one will have it look at our sphere. The problem is, where is our sphere? Our sphere is now movable. But just like we can say position 1, 2, 3, $1, $2, $3, we can also say look at $1, $2, $3, and use the same multi-slider to control the position of the planet and what the light is looking at. We can actually use either one of these lights. We'll just use the top one here. So now we've pointed our light directly at our sphere by telling this light, because it's a spotlight, to look at the planet. So the planet, wherever it moves, it's not much of a planet because it's right over a city, but if we put it over here on the horizon more and maybe tilt our camera down a bit. There. Now it's more like a planet up there in the sky. Our spotlight is following the planet so it remains illuminated. Right now our sky is not very interesting. You can actually send an image directly into jit.world. So if I say jit.noise 1 float 32 1000 by 1000, I can send that into my jit.world, and it's going to make a random noise sky image for me. Now that's not a great sky. That's static. I mean, that might be cool for some application, but static sky is not what we want, and it's not filling the background very nicely. So we need a new attribute of jit.world, which is preserve_aspect 0. So with preserve_aspect 0, our static will now fill the sky, and that's nice, but still we don't want a static sky. But this is very easy to convert into some stars. If we say jit.gen, one of the things we can use in jit.gen is greater than and less than. And greater than and less than return a 1 if they're true and a 0 if they're false. So we can look at these random numbers and say, hey, are you greater than 0.99? And if they are, they'll come back as 1, which in this case will show up as white. And if they're not, they'll come back as 0, which will show up as black. So that's an instant starry sky generator. And those stars are pretty dense. We can even say greater than 0.999, and that's going to give us a sparser, starry sky. So it's just a quick trick for generating stars, and we can connect this right up to receive start so that our starry sky is generated every time we start the patch. And we're going to look much more at greater than and less than. This is just a simple introduction to it. Basically what it's saying is, because these are random values, 1 in every 1,000 dots will be white. And also, you see how we use jit.noise 1 here, because jit.world is helping us by automatically interpreting a one-plane image as a black and white image. Ordinarily, we'd have to put the red, green, and blue equal to the same value to create shades of gray. Here, we're creating shades of gray simply by specifying that it's a one-plane jit.noise. And it's going to give us, every time we click this, it'll give us a different arrangement of stars. So now we're really getting someplace, right? We've got this dramatically lit, randomizable city. We've got a randomizable planet, but we've also got a way to save a particular set of stripes on the planet. And you could use this to save a particular arrangement within the city if you wanted to as well. The last step in this is we want to be able to move things. We want to be able to animate things. To do that, we're just going to look at a new object, which is pattern storage, and which takes a name. We'll call it params, or call it whatever you want. Doesn't matter. It's in all caps. Pattern storage params, and it needs along with it an auto pattern. And these will autocomplete for you if you just start typing them. Pattern storage params, auto pattern. This allows us to take any user interface object, of which we currently only have one, our multi-slider, and save that into a file that's part of our project. So the way we do that is we use attrui, A-T-T-R-U-I, connect that to the object we want to save, lock the patch, click it, and select scripting name right here, scripting name, and it's going to show up as var name. And var name is what this stored multi-slider is going to be called in our pattern storage. So we'll call it planet position, planet pos. And now if we double click our pattern storage, we'll see we have a slot for planet pos. And we can then use this to store cues. So we make a message and say store 1, and click it, and now this is stored as position 1. We'll move the planet, and we'll say store 2. And to recall them, we simply send that number. So to go back to position 1, I click 1. Now our planet is moved back to position 1. To go to position 2, I click 2. Now our planet is moved to position 2. And that's all well and good, but we want it to move between those two locations. So how do we do that? That's our last new object, which is line, which takes 2 arguments, which you can just always use 0.20. And then a message that is starting queue, comma, ending queue, space, amount of time. So starting queue of 1, comma, ending queue of 2, and then amount of time expressed in milliseconds or thousandths of a second. So if you want this to take 5 seconds, you say 5,000. 1, comma, 2, 5,000 will cause it to go from Q1 to Q2 over 5 seconds. And there it goes. And if you want it to go back, you say 2, comma, 1, 5,000. From Q2 to Q1 over 5 seconds. So now we have motion in our patch. The last thing we need to do here is to save this pattern storage. We do so the same way we did by saving a matrix. We send a write message, and it will write params. And we don't want to write it into the patchers folder. We want to write it into the data folder, which we don't have a data folder right now. So it will create one for us. So for right now, we can save it in params into the patchers folder. And take the read message to read it back in. And it's the params.json in the patchers folder. But if we cancel this, save our project, close our project, open our project back up, and look at the project structure, we'll see that it has created a data folder, and it's put our params and our planet colors into the data folder for us. So even though we saved it into the patchers folder, Max moved it into the data folder because that's where it belongs. So let's go back into our patch, turn it back on, and make sure we can get everything back. Can we get back our random city? Yes. Our lights are working. We automatically got back our colors because we had receive start connect to read planet colors. Our pattern storage also looks like it automatically loaded up for us, so we didn't even need to read it. It found it in the data folder, so that's great. Let's take another attribute. Let's take, for instance, the rotation of our buildings. So I'm going to use my snippet here, multi-slider, 3 sliders. It made me a new one. Here it is. And I'm going to use it to rotate all the buildings. So I'm going to say target 0, rotate XYZ, $1, $2, $3, and send that into the physics input of my poly. And now I can rotate all my buildings with an interactive control. They're not rotating very far though. Why is that? Well, that's because my range of this multi-slider is set to, we can look at what it's set to by clicking on the eye here. It's set to -10 to 10. So that's only a 20-degree range. And of course, there's 360 degrees in a circle. So we want a much bigger rotational range here. So we'll make a message, set min max, -180 to 180. Now we're going to get the whole rotational range, 360 degrees, on the x-axis, the y-axis, and the z-axis. And that's pretty hip. Get a lot of different stuff going on there. And of course, we're going to want to potentially save this as well. Got to bring back to 0. So in order to save it, it needs to have a var name also. So we can just take this adder UI that we've created here, make a little space for ourselves, and connect this adder UI to this multi-slider and call it BLDG rotation. And we'll see immediately in our pattern storage a building rotation line has been created for us. So now we can save rotations into our queues. So if we go back here to queue number 1, change the building rotation, and store 1 again. Then go to queue number 2, change the building rotation, and store number 2 again. Go back to queue 1, and now when we go from 1 to 2, our planet's going to move and our building rotation is going to change. And of course we can add additional queues. So store 3 is going to store a third queue, and we can make another message here to go from Q2 to Q3 over another 5 seconds, say. And in Q3 we can have some other rotation and some other position for the planet if we want. So store that as 3. Go back to Q2, now travel from Q2 to Q3. So now we're really animating.